All right, hey everybody. So today I'm going to kind of be talking about basically how to walk through stoichiometry problems with you. All right, and as we do this, I'm going to be flipping back and forth between that computer screen and this computer screen, and kind of showing you what it is we will be doing. All right, so real quick here, if I pop this thing up, let me just pull pull up the assignment right here. We're going to be solving basically how many grams of O2 are needed to react with 25 grams of Fe to make Fe2O3. Now earlier this week I completely messed up on this and I had FeO3 which doesn't actually exist, so it's Fe2O3, and that is what you should be solving for. Sorry for that error. If it confused you, made this problem hard, I apologize, and I corrected it. So if you guys ever see anything like that and you see that it's wrong, feel free to just let me know, um, and I'll definitely fix it for you. Okay, I'm getting all kinds of notifications right now. All right, so that being said, let's go ahead and figure out how to do this problem. So the first thing is we have to look up our ratio. Okay, and here's a good example I found online that had a good picture of that. So let me just pull that up here. So if we go ahead, it shows us how to balance, basically step by step. So we start by making sure, one, we are not a wizard, and two, that our numbers make sense. So we can't create or destroy molecules or energy or matter or energy, right? It can only be transformed. Okay, so we have Fe3. That means we need to have a 3 over here, and that's exactly what this guy does, all right? So next, we have 4 oxygen, and we don't have 4 oxygen over here, so we have to balance that out. So we have 3 to 4, and there we go, 4, 1, there we go, 3, and we are set. Now, this guy does it with water. You don't have to do it with water. You are more than welcome to do it with just oxygen, okay? And that balance looks a little bit different. So let me pop up an alternative video for you guys right here, which is going to be what we're going to be doing today. So let me just whip that around. Pop this up. Now this guy kind of sounds a little bit like Microsoft Sam if you listen to him on this video here, but we're going to be using this equation. So 4, 3, and 2. All right. Now we're given 125 grams of iron. So usually when we break down problems, what I want you guys to do is just start by writing down your given. That's always going to be the first part of your written bar thing. So when you write it down, make it look like this, okay? Draw a straight line going right across, and it will make a lot more sense. So you're given 125 grams, okay? Now what's wrong with that? It's in grams. And this ratio you see over here is going to be our molar ratio. So what we have to do, well, we have to transform that to moles. How are we going to do that? Well, you got to get out your handy dandy periodic table and look at iron, which is also sometimes referred to as ferrous. That's why it's Fe. Okay, and if you take a look at Fe on your periodic table, right here, all right, Fe is going to be 55.847 atomic mass units. All right, and so what do? We write that down in our little T bar. Okay, so go ahead and write that down on the bottom over here. So in 1 mole, write that down, 1 mole goes on the top. We need 55.847 grams of substance. Okay, and that's roughly going to give us 2 1/4. I'm pretty sure if I do that right off the top of my head, it's going to be like 2 1/4. Okay, moles, somewhere around there. Okay, next, what do we do? Well, now that we have that part figured out, now we have to do our molar ratio, right? So we go ahead and we take a look at this problem, okay? And we're given iron. Now when we look at iron, which is right here, it's 4 and 3, okay? So we have to write out a ratio there where we're going to be multiplying it by a fractional amount. So what can we say? How are we going to say this ratio that's going to make sense? So we could say for every 3 moles of oxygen, so I'm going to write that down real quick. So we say for every 3 moles of oxygen, we're going to have 4 moles of iron. Okay, and again, you can kind of just flip this around. Let me get that camera towards you. So for every 3 moles of oxygen, we get 4. All right, so we're going to multiply it in our thing here by 3/4. All right, and I went ahead and I wrote it out like that. So 3/4, and I labeled it Fe in oxygen. Okay, so that's what I know. That's how I know what I'm doing. I like being very explicit in my problem solving techniques. That way, I can always tell later if I messed up, which happens fairly frequently. Okay, so next we have to figure out our gram amount of oxygen in our moles. Okay, and that's what we're going to be multiplying it by. Okay, so if we go ahead and I flip this puppy around, so if we look at oxygen there, oxygen in that problem is O2. Okay, and oxygen on this is going to be roughly 16. Okay, so it's 15.999. Okay, oxygen's a number you can just embed in your brain forever. It's 16, always 16. So 16 times 2 is 32. Okay, so we write 32 on top, and that's grams, because that's going to be our molar value. And we'll write O2 in 1 mole. All right. Do you see how we're just doing this one really long bar here? Okay, you guys can pause this if you have to. I know this is flipping around backwards to me. I can't really make sense of it on here, but hopefully it's facing forward for you. Okay, so we have 32 grams in 1 mole. Okay, and now with all of these, we have our grams to mole. That cancels. Now we're in moles. Moles to the molar ratio. And then after the molar ratio, we divide by moles, so now we're back in grams, and those grams will give us our final answer. Okay, so what you're going to do is you're going to pop that in on your calculator. Okay, and what you're going to do is, if you write this all out on a very simple calculator like this one, all right, you take your 125 grams of iron, you're dividing it by your molecular weight, which is 55.8. All right. Then you multiply that by 3, and then you divide it by 4. So you go times 3 equals divided by 4 equals. All right. Should be getting some number close to that. Right up there. Okay. And then you multiply that by 32 because that's how many grams are going to be in each mole. Okay. And that should give you roughly 53.7 grams, okay, of oxygen, okay, and you have to write that out. So let me just go ahead and go, this equals 53, let's go 4 grams of oxygen. So here is my full work, okay. Now I have 3 sig figs there. Now I should have 4 sig figs there. So what I need to do is I need to carry it down, and I need to go 53.7 grams of oxygen, O2. And then I'm going to circle it. That way Mr. Bodwin knows that's the answer. Okay. Now, if you guys want to see this in a little bit better resolution and a little bit clearer, let's see if I can pop this up on here. So let's see if I can zoom in using this thing. This was taken from a worksheet. All right. And so if my work's not good enough for you guys to figure it out, here's this one. So what's the first thing we did? Well, the first thing we did is we took our grams of iron and we looked at our ratio on here. So we figured this part out. All right. So we knew we had to get iron oxide, had to be our last thing. We had to get rust, and we're given iron, and then want to know this. Okay. So what do we do? Well, first thing we got to do is we balance this out, and once we have that balanced out, we take our grams of iron and we have to convert it to moles. All right. So 125 divided by 55.85, and you're roughly going to get 2.24 moles. Okay. Then you multiply it by the ratio That's in here. It means for every 3 of these, we have 4. So you multiply it by 3, divide it by 4. Okay, so it's getting smaller. Here we have Wolfram Alpha. Let me just go ahead and get that thing out of there. All right, so it's getting smaller at this point right here, which makes sense. And you often have to ask yourself while you're doing these problems, is this making sense? Okay, and why is it getting smaller? Why does that make sense? Well, O2 weighs a whole lot less than a metal. Okay, so a gas weighs less than a metal, so that is kind of making sense. And then we're multiplying it by 32. Okay, so it's getting smaller and then it's getting bigger. Why is it getting bigger? Well, because we're going from this ratio of moles to grams. So we're going to have more grams than we will of moles in almost every kind of circumstance. Okay, so even hydrogen, it's pretty close to a 1-to-1 ratio there, but I'm kind of getting sidetracked on that. So, right, now we have our grams and we're in grams. So if we look at this and we go diagonal, we can go, okay, 1, what we're given, so 1 given, all right, and divide grams by grams, now we're in moles. Moles by moles, we're still in moles, all right, moles by moles, and now we're in grams, okay? And then grams, grams, everything figures out. This looks like a very nice problem. I like this format. If you guys have any questions, let me know. I'll try to post a couple more problems like this later this week, and I'll kind of break them down again for you. Okay, so here again, just outlining this whole problem. We're given this, and then we divide it by the atomic weight AMU, or the molar ratio. All right, and so in 125 grams, we have to figure out how many moles are in there. So we divide it by the gram amount that makes the moles, and that gives us our molar ratio. Okay, now we go to our equation, and our equation will give us our ratio that we need to figure out this problem, which is 3 to 4, because we're trying to figure out oxygen. All right, so it's 3 divided by 4, and that is where this is coming from right here. Okay, and finally we have 32 grams in every 1 mole of oxygen, and we end up getting 53.7. Okay, so if you guys have any questions, anything like that, let me know. Hope this was helpful. Hope this wasn't too confusing. Let me know if there's anything I can do better. I'm really trying to work with a couple different technologies here to try to make things a little bit easier for you guys, or diagram stuff a little bit better. Yeah, so let me know. You got my email. If you want, I can always walk you through a problem over the phone or through Zoom or whatever you need. So, hope you guys are having a great week, and I'll see you later.